Okay, we're going to do some normal distribution questions. So, this says for Z is modelled as a normal distribution 0, 1 squared. So that means we're dealing with normal distribution, its mean is 0 and its standard deviation is 1. We're told the probability of Z is smaller than 1.26. Now that's exactly how it's given in the back of the book, and if you're using the Zeckley cross method, that means it's 0 changes. So we can just read out from the back of the book. We find 1.26. We therefore know that the probability that Z is smaller than 1.26 equals 0.8962. And that's it. That's our first question. Question 2. Again, we have the same probability, but now we're told that Z being bigger than Z is 0.3. So we're going to have to use our other table, and we're going to have to use the reverse Zeckley cross. So we know the probability of it being bigger than this point is 0.3. That would be 2 changes from our general here. It's bigger than, and that's a smaller than 0.5. Therefore, we can read it straight off. And what we get is that Z equals 0.5244. Done. Okay, question 3 is quite a nice one because it's actually the real numbers taken from something. The IQ is defined as having a mean of 100 and as a standard deviation of 15. What that means is that this is real. We can actually use this. So we want to find the probability that a random member of the public has an IQ of 130 or higher. Now I'm going to call this X, this distribution. So X is modelled as a normal distribution with 100, 15 squared. Okay, and we're wanting the probability that X is greater than or equal to 130. Now here I want to remind you that greater than or equal to 130 is exactly the same as it being just bigger than 130. Okay, so we don't have a table for this sort of normal distribution. We have to code it first. So our coding formula is Z equals X minus mu over sigma. So that equals 130 minus 100 over 15. That equals 2. So we're actually being asked for the probability that Z is bigger than 2. Now, using the Zeckley cross method, we have one change. So we can look at the back, we can find Z equals 2 from here, and we just do 1 minus that probability. So it's 1 minus 0.9772. So this is 0.0228. That's question 3 done. So now we move on to question 4. So we have a normal distribution with a mean of 46, standard deviation of 9. We've called it X again. So again, it's a normal distribution. Therefore, X, we'll do that in black instead, X is modelled as a normal distribution 46, 9 squared. Remember the squared, otherwise you might get confused and think it's just 3. And we want the probability that X is smaller than 50.5 and bigger than 37. Okay, first thing we're going to do is we're going to convert these over to Z. So Z equals X minus mu over sigma. So our first Z value equals 37 minus 46 over 9, and that equals minus 1. Our second z value equals 50.5 minus 46 over 9, and that equals 0.5. So what we're actually dealing with is the probability that z is smaller than 0.5, bigger than minus 1. Now, I'm going to draw this one quickly, just so that you can all see what we're talking about. We've moved to z, so that's 0. We've got 0.5 here. We've got minus 1 there. Now we want this area. So when you have a question like this, you can rewrite it as the probability of z being smaller than 0.5 minus the probability of z being smaller than minus 1. Now I know I've just swapped that sign, that was intentional. That's because we want this whole area minus this area, not this area minus this area. So now we can look at this. This one, that's exactly normal. So all we have to do is find z equals 0.5 in the book, and we get that to be 0.6915 minus. Now this has one change. We have a negative, so we're going to have to do 1 minus. 1 minus the probability of z equals 1. 0.8413. So this is 0.6915 minus 0.1587. And so that finally equals 0.5328. And that is it.